Hello and welcome to the first in a short mini-series putting INAV onto this model here. This just happens to be the latest wing that I'm having here, so we'll do it on this one. This is the ZOHD Alpha Strike, but the process that you go through to put INAV onto a fixed wing model is almost identical. The only thing different is choosing the mixer. So with something like a wing, you're going to have two elevons. With a more conventional plane, you're going to have things like elevator, rudder and ailerons, and they'll be separate. But that's the only difference. Everything else is exactly the same. Now the reason I'm making this video is because at the moment the INAV wiki is still playing catch up with version 3.0, and I'm sure at the end of this year, beginning of next year, we'll have INAV 4.0. So things may change subtly again, but it's definitely worthwhile making this more detailed setup video, because now I've been playing with this stuff for a little bit longer. I have figured a lot of it out, and it takes me a very small amount of time these days to flash and set up an INAV model. So I want to go through this at a fair pace. So if you are brand new to INAV and you've never really had a look at this stuff before, I wouldn't start necessarily with this particular setup. I'd go back and watch the INAV for Beginners 2020 series. The setup is almost entirely the same, but there are a few key improvements in how fixed wing leveling is done in INAV 3.0 over the previous versions, and we'll cover that in a little bit more detail now I've figured out exactly how that stuff all works. The nice thing with INAV in something like a fixed wing is you don't need to install a compass. Now there is a companion series to this one where I've installed INAV into a multi-rotor, and you absolutely need to install a compass in there and have it calibrated really well. And that can be a little bit tricky because the compass is going to be pulled out of true by any stray electromagnetic fields on the model. And in some cases we're throwing around some pretty heavy electrical currents, and those will generate an EMF field that will pull the compass. On a plane, we potentially have a little bit more room to put the compass well out of the way of all the other electronics. I typically will sink it into the top surface of one of the wings, but actually you don't need a compass. I have a video here that explains why that is the case, and I'll put a link down below so you can go and have a look. I'll try and get through this stuff in as few videos as possible, so let's go onto the bench and start flashing this model with INAV 3.0 and setting it up ready to go to the field. As usual with INAV, I would recommend that you set a brand new model up on your radio. If you already have an INAV model that you use for other things, you can just cut and paste it. You can use the same INAV model on the radio for fixed wings, flying wings, full-size fixed wing, cars and boats actually. The cool thing is all you need to do is add an extra couple of channels, one for arming and one for modes, underneath the four standard controls that you're going to use for throttle, aileron, elevator, rudder. While you've got the radio out, it's also handy to install the INAV Lua script. That can be incredibly useful at the field to monitor to make sure that you have a GPS lock before you fly. So here on the bench is the model ready to go. Now everything is connected already. I'm not really going to cover that in too much detail in terms of the hardware wiring, because if we jump on the computer and look at the Maytech stuff, these guys are fantastic at showing you exactly how everything fits together. Now I'm using a Maytech 411 WSE inside this particular model, and down here is the wiring and settings, and here we have it for INAV Airplane. It shows you exactly how to plug everything in. So for example here, the Maytech GPS, which is actually under this little sticker here at the side, is connected to UART1. That's TX1 and RX1, and that is here on the model itself. Similarly, the receiver, which is an S-Bus receiver with smart port, is connected here on the flight controller, and the smart port telemetry is going back, and that's connected to TX2. So everything in here has been wired up as per the diagram. Now I have also removed the prop from this particular model. Really important, we are going to have to apply main power at some point during this setup to align all the control surfaces and make sure the movement is okay. So it's incredibly dangerous to have the prop connected. So I would recommend, if you're ever going to attach power to a model like this, make sure that that's the case. So with all that said, let's download the configurator. So on the computer, we're going to scroll down in the INAV wiki. Again, links to all this down below, and we'll download configurator. Again, just like all of the others, we'll download the Win32 version. I could probably use the Win36, but let's open the file in Windows Explorer and copy it into a location. Now, I would always make sure with this that you, if it's already on a previous version of INAV, back up all the configuration. It's going to be an awful lot happier. So here we have INAV configurator that we've just downloaded. That was really quick, wasn't it? So what we'll do is we'll copy that. We'll go onto the desktop and we will paste it into the new folder. Now this is all you have to do in terms of the INAV pieces and you're ready to go. Although if you're an INAV pilot, none of this is going to be new to you. And if you're a beta flight, actually, this is going to feel very, very familiar. So now we have the configurator. We can go in here. We can run the application. The computer may tell you that it's not happy because it hasn't run that particular file before. So to be ready to tell it that you are happy. And then let's plug the flight controller into the computer using a USB cable and get ready to set everything up. Now, I'm going to click on connect, and the first thing I'm going to do, I'm going to ignore everything because we're going to completely blow it away and start again. I always come in here, type in version, just confirm which version of the Maytech bits you want, Maytech 411SE. So we'll disconnect, go into firmware flasher. We will select Maytech, pressing M on the keyboard will take us down there, 411SE, choose the latest firmware. We want a full chip erase, that's important to make sure that none of the older settings are going to cause us a problem. We'll scroll right down to the bottom and we'll click flash firmware. So this, as usual, is going to erase the flight controller and then install INAV in a base configuration. Top tip is always back up your previous settings if it's already been flashed with something else. You cannot import the settings from old versions of INAV, and you definitely can't import the settings from things like Betaflight. I would always recommend with things like a fixed wing starting from scratch because you'll end up with a much better setup, particularly at the moment where so much is changing in INAV around optimizing it for fixed wing. It's great to be able to make sure that you don't accidentally import a setting that's going to cause a problem. So now it's all been set up. Let's give it a moment for the flight controller to boot. There we have it, and we'll click connect. First question we're going to get is, what kind of model is this? Is it a mini quad, or is it an airplane with a tail, or is it an airplane without a tail? That's what we want. That will then reboot this, and it'll reboot and come up in the default settings for this particular model type, and then we can run through all the settings as normal. Again, I'm not editing this bit, I'm going to show you every single step. First thing we need to do is go in calibration. You can see here we have a red mark that says the accelerometer isn't calibrated. You want all these pre-arming checks to be green. If they're not, it's not going to go. So we need to check that as one of the last things. First thing we need to do is calibrate the accelerometer. We need to put it in 6 specific positions. So I need to put it level and then click calibrate. And then we need to put it in each orientation. Now, having the side of a desk or something is very handy for this. I like to try and do this outside of the model when I'm setting up the flight controller first time. And this is just teaching INAV what each of the individual positions are like. Again, trying to do it can be a little bit tricky. Okay, we need to do it facing up. Take your time with this because this is the reference that the model is going to use to fly with. This is the basic. So we'll click calibrate. Okay, and we you will say save and reboot. Now the cool thing is, because we're not using a compass on this fixed wing model, I'm not going to be flying it in high wind, so I don't need to, we can skip the whole compass calibration stuff. That's going to make our lives a little bit easier. Now at the moment, this is not lying flat because it has an antenna at the bottom, but if I kind of put it flat, that's pretty close. Actually, I'm happy with that. Next thing we need to do is go into the mixer and load it. At the moment it's showing that we have the airplane mixer preset, but it isn't applied. We can't see anything in the servo mixer. So we'll say load and apply. This is also going to say where we need to plug in each of the individual servo outputs on the flight controller. And now we have the right graphic on the screen that moves in the right way. Just confirm at this point that when you lift the nose lifts, and when the wings go left and right, they go in the right direction. That's all looking really good. Outputs, we'll come on to this last. I would keep the standard ESC protocol. On a fixed wing, we're not bothered about BL heli and any of that stuff. But we will probably end up having to change the offsets on this. And we're probably going to have to also change the direction as well. So we'll come back. This is one of the last things we're going to do. We'll probably do this in the next video. In terms of presets, we have airplane with a tail and airplane without a tail. Let's apply those. That'll give us a good starter for 10. I would always recommend, because there is an auto-tune feature in INAV, using auto-tune to get your model dialed in. In my experience, it's actually pretty good. I fly an awful lot, even though I use INAV in manual mode, which is where INAV isn't doing anything apart from giving me the OSD. It tends to be used more for auto launch and also things like the return to home in the event of a problem. In terms of ports, we need to set these up. So as per the standard wiring diagram, GPS is plugged into UART1, we saw that. So we will turn off MSP, but we will turn on the GPS. And soft serial, it would actually be tramp. Let's save and reboot. And then when that comes up, we're ready to go into the configuration tab, where there is a lot of stuff that we need to set. So in configuration, at the moment, the GPS isn't showing, the magnetometer isn't, because we're not setting that up. As we go down here, everything is pretty standard. There is something called fixed wing level pitch trim. Now, we need to set an offset a little bit, because actually what happens is when you're flying, the nose of the model is slightly up. Now, normally in a regular conventional fixed wing aircraft, that's usually 3 to 5 degrees. In something like this, it's actually going to be an awful lot more, something like a delta. So I would go into the CLI, we'll type get, and here we are, pitch level trim. So we'll say set pitch level trim equals, for something like this, I would be very generous and say about 8 degrees is going to give us a nice safe position to start. Let's save that. And then we'll go back and carry on in the configuration tab. In my humble opinion, I still think that should be in the configuration tab. Jumping into the CLI is just a bit fussy. Okay, so now if we carry on down, we've got the alignment done. Now we're going to turn on the GPS. That's something else that I would check. And then we can also in here change the Fat Shark band that we want to use, or the race band, whatever it is for the VTX that's attached. And I would also do a couple of things. Permanently enable air mode for a fixed wing, which is a good idea. Permanently enable launch mode. So that means when you arm it, it immediately goes into launch mode and is ready to throw and climb on its own into the air. I love launch mode. It is my favorite way to do it. Even with an average throw, it'll save and rescue the model and take it into the sky. Last one here is continuously trim servos on fixed wing. This, as you're flying in a self-level mode, will figure out what the servos need to be for straight level flight in manual mode and set those up for you. So when you go into manual, it's all done, and it continuously does it as well. So if you slightly change the central gravity, that is going to take care of it. So we'll save and reboot that. Going into the failsafe tab next, we're going to make sure that that is set to return to home. We'll save and reboot it again. Return to home will return back. There's loads of settings that you can change for return to home. We'll probably get a chance to look at those in the next video. But by default, that just means it's going to come home and circle around the home location. And then now we've done that, PID tuning we're going to take care of with an auto tune. The default auto tune is going to give it a very basic PID settings. We'll end up tweaking these quite a bit. Rates and expo will also be calculated by the auto tune. Historically, before INAV 3.0, you had to kind of figure out what the rates would be. Now you don't have to. Advanced tuning tab. For a fixed wing, there is loads of stuff in here about how everything works. And I normally, for a fixed wing like this, change a few things, but we'll come back to this tab in a minute. For example, things like the climb angle, 18 degrees is fine for most things. I would increase it slightly for a first throw just to make sure it climbs like a lovesick angel, is how my friend describes it. Things like what the throttle it'll use for cruising, all the stuff is in here, including how return to home works. So we'll spend a little bit more time looking at that potentially in a future video, but for a basic setup I would just leave it like that for now. Receiver tab, let's turn the receiver on.
Welcome to OpenTX.
And what we are looking for is that when we move all of the controls, they're in the right order. Standard stuff, the mapping is wrong for the radio that I have here, so we'll change it to the one that's going to match it. And that's going to be throttle, aileron, elevator, rudder. Again, this radio has the stuff on here for the Lua script. I'd recommend you doing that. Let's jump back in the receiver. So there we have the throttle and everything moving. We want to move the sticks to the top right hand side and make sure they go to their maximum setting, which they do. You never do any mixes on the radio.
Telemetry lost, telemetry recovered.
The mixing is all done within INAV, so that looks really good. We've also set up on channel 5 an arming switch, and I've also set up on channel 6 even an arming switch, and on channel 5 the modes. Most people have it the other way around. It's a legacy thing for me. So first of all, we need an arming setup, so we'll change that for channel 6. I would recommend that for the first flight you have horizon as your base mode. We have something like nav position hold, and then potentially nav return to home as the 3 modes to initially try it in. That way it will allow us to kind of test, just like we did with the quad, kind of test the basic settings first, and then have the other 2 that we can go into, and we can always go back to horizon if we really want to. The only other thing that I would set up is auto tune. Put that on one of your spare channels. That is going to allow us to actually tune the model and have all that stuff done. At this point, we're starting to get close to the end of the initial setup. OSD is worth a visit. The on-screen display is standard stuff. If you're a Betaflight pilot, this is going to feel very, very familiar indeed. I would move everything around to suit how you want it to work, and also upload the latest and greatest font. Just the INAV stuff has extra special characters and things for some of the cool stuff that it does. So that will allow you to see everything. If you don't upload the font, you probably get an invalid font error when you first boot it up. Using the goggles to look at what the problems are if you're having an issue with the field arming is incredibly useful. So making sure that the font is up to date is a big help. Okay, one last thing we are going to do before we carry on, and that is to actually plug in a battery. And what we're interested in is, do the control surfaces work in the right direction, and are they at the right position? So we're not going to bother too much right now about the radio, but I will turn it on.
Welcome to OpenTX.
Let's plug in a little 2S battery. Again, this is why we do not have the motor plugged in. So get ready. There we go. Now the GPS has locked up. All that screaming from the alarm was letting us know that's the case. Now at the moment, the reason that the ESC is just beeping is because it isn't receiving any signal from the flight controller. And that's because in outputs, we haven't enabled motor and servo output. So we're going to leave the servo refresh rate at 50, which is analog servos. We're going to leave the ESC refresh rate as standard. We're going to turn this on and we're going to say save and reboot. This time, when it reboots, what we'll find is we will have, there we go, everything's kind of connected. She's kind of ready to go. Now, I can move the sticks. There we go. So if I move the stick to the right, we can see both the controls are moving up. So what we need to do, we need to go into the Outputs tab.
Telemetry lost.
We need
Telemetry recovered. Telemetry
to
lost.
scroll down.
Telemetry recovered.
The radio is way too close for this. But if I pull the elevator down, we can see that this control is moving upwards, which is what we want. This control, however, is moving downwards. Now we know in here that one of these is wrong. So if I click reverse and save, they're both now moving in the right direction. Now they're not going to move in fully, but because we're in a self-level mode, if you want full movement, if we put it into manual mode, it would move better. But that looks good, and they're all moving in the right direction. If you ever do this and you can't get them to work properly at all, it probably means that you've probably got
telemetry recovered. Telemetry lost.
Radio keeps losing connection. You've probably got the servos plugged into the wrong way. The other thing we can do here, let's turn the radio off for a moment, is we can check and change the middle channel position. So if we enable live output, we can then change the numbers here and then watch what actually happens to the position of the control surfaces. And this is the way to kind of get them into line. Just you work your way through this just to set them how you want. Okay, so we'll say save. We'll unplug the main power. And then what we'll do is we will disconnect. Now at this point, we're in a really good shape. We now know that the radio stuff works. We've got our control surfaces aligned, and if you had something like a larger plane, you'd obviously go and you'd actually work your way through the elevator's rudder and everything else. Join me in the next video where we will complete the setup, and then we'll go out to the field, test it all, and actually do the auto tune and look at the results. Thank you for spending your time today watching that video. You can find me in all the usual places on social media, and if you're trying to learn about a subject, then check out the playlist. All of my videos are organized into easy to follow playlists that if you're trying to learn a topic will take you from the basics right the way through to some pretty advanced stuff.